Welcome to the Chicago, Illinois, and beyond quantum computing user group. Today's session, our speaker is Tamás Varga. He's the founder of Edu Lab, and currently he's a postdoc in quantum software engineering at the Constructor Institute Schaffhausen. Did I pronounce that correctly? Schaffhausen?
Yes,
okay.
Perfect.
Close enough. All right. He's going to talk to us about Niel's chess, the quantum game for schools and the general public. Tamás, take it away.
Okay, thank you very much for the introduction. I would like to welcome everybody. I'm happy to be here. Thank you very much for the invitation. So let me share my presentation first. Just a moment. Okay, and I will try to bring the chat somewhere where I can see it. Okay, so
I can keep an eye on the chat for you.
Okay. So I hope you can see my screen well.
Yes.
Okay, and I will leave it like this because sometimes I might need to edit things if we go into chess situations. Okay, and yeah.
So I understand about you saying you may need to edit things, but just to let you know, I have a vision disability. So if there's any screens that have smaller text, I may not be able to see it like this. I'll let you know if that happens.
So okay, I don't think that will be a problem. So you will see things like this big, and when I say edit, I mean something.
I can see that. I can see that. That's fine.
Good. Okay. Okay. So let me start. So my name is Tamás Varga, and today I will talk about Niel's chess, which is a quantum variant of chess. So here is the agenda for today. I think it will be about 1.5 hours. That's my estimation. First, I will talk a little bit about me, not that much, and then I will talk about what is Niel's chess, and then I will introduce some essential rules of the game. So I don't want to go into all the details so that not to overwhelm you. And then I will tell you how I think we should play the game in general. And then we will solve some puzzles, some chess puzzles, including some examples from real historic games. And then I will talk about potential variants of the game, and that will conclude the talk. Yeah, so some words about me. As Barry mentioned, I am a postdoc at the Constructor Institute, and my topic is quantum software engineering, and I am working on a high-level quantum programming language in which you can put numbers, strings, or booleans, or other data types into superposition, and you can manipulate them. So, and secondly, I am interested in quantum technology education. I set up the website qedulab.com, which targets mostly people with IT background. And this is the place where Niel's chess was actually born. And thirdly, I am also selling SpinQ's quantum computers for the classroom. You can see some pictures here. So now let's go to Niel's chess. So what is Niel's chess? Niel's chess is a chess game with quantum rules. Basically, the game starts in the usual initial position of chess, and the usual rules apply, except that there are some additional quantum rules that you can create superposition, entanglement, tunneling, and other quantum effects on the chessboard, basically. And the game has a risk management aspect, because it's all about problem solving in an uncertain and interconnected environment, just like the world that we are living in today. And the specialty of the game is that no computer is needed, although this game is about basically a cutting-edge technology, but you can play it on a on a traditional chessboard. But that said, I will make the game available online in the coming months, and you can see the screen plan on the right side. And I will make it available online so that it can reach more people all around the world. And my hope is that Niel's chess will contribute to quantum literacy among people in the world. I already did a small pilot with a couple of children between ages 10 and 12. And my conclusion is that they can understand the rules and they can play the game. And here is a paper that you can read later. And here is a QR code, but Barry will send you the presentation and you will have it.
I'll send it if you send an email. I'll give that information later.
Yeah, and anyway, if you just Google for Niel's chess, you will definitely find it. So now to the rules of the game, the essential rules. So I will not talk about the normal chess rules. They all stay the same. I will talk about the additional quantum rules. And the first is superposition. So here, basically, in this situation on the screen, just a moment, I will try to make it a bit smaller for myself so that I can organize my screen better. Okay, you can still see it big enough, right? Okay, so in this situation, okay, good. So in this situation, the white knight could, for example, attack the black queen, but of course, the queen would escape very easily, or it could attack the rook, but of course, again, the rook would escape very easily. But in Niel's chess, it is also possible that you do both at the same time, because the knight can go into superposition. It can move to both places at once, and now it is attacking both the queen and the rook. So I don't know. So can you see these two, which I show, these two chess pieces? And yes. You can see here, one has a red mark on it and the other has blue. And now if on the chessboard you can see such a pair, then this basically represents one knight, not two, just one knight, which is here and here at the same time, okay? In two places at the same time. This is what you can see on the chessboard, that these two pieces, I call them indefinite pieces, and they represent one knight being on two squares at the same time. So now, as I said, it is attacking the queen and the rook. So the queen is the more valuable, so let the queen escape. And now the knight tries to capture the rook. So now what happens is, you all know, I think, that superposition states are extremely fragile and delicate. And now basically the knight kind of bumped into the rook, so now it is disturbed, and that's why the state will collapse. Now, according to quantum mechanics, the collapse is truly random. So now we have to roll the dice. And the rule is that when we roll an even number, that means that the piece will collapse onto the square with the red mark on it. And if we roll an odd number, then the piece will collapse onto the square with the blue mark on it. So this here, yeah, God doesn't play dice, but we do. We are not God. So here...
Gosh, can I interrupt for a second? Can you go back to the one or two slides?
This one?
Yes. And now, if you go forward.
Yeah.
And now one more. Oh, okay. So the queen moved. Okay, got it. Yeah.
Yeah, because it
looked without noticing, I thought it was that the knight ended up in a different position. The red knight ended in a different position than the one where they started, but it's the queen.
Okay. Yeah, yeah. I mean, maybe in quantum mechanics it can happen.
No,
Okay.
it's just a visual. I just
Yeah,
just
yeah,
wasn't watching that part carefully.
Mhm. Okay. Okay. So then okay. So the knight attacks the rook, and then it is disturbed. So since the superposition state is fragile, so now it will collapse. And we rolled a 5, which is an odd number. So now this means that the knight will collapse here on h7. So it collapsed exactly on the same square where the rook stands, and that's why the rook will be captured. So here white was lucky because it attacked the rook, and it really succeeded in capturing it. So this was the random collapse. And then if we go further, I will show you here a situation which is similar to the previous one. And here the knight again goes to superposition, just like it did before. And now the king is in check, because now the king is at risk of being captured. And this is called a check. And that's why the king has to get out of check. So let's do that. The king gets out. And now the knight can attack the queen, tries to capture it. And again, now the superposition will collapse. So we roll the dice. This time it's a 2. It's an even number. So even means red. So now the knight will collapse here, right next to the king. Let's see that. It collapses. And now the queen has escaped, because now white was not that lucky. But still, white doesn't have to be too sad, because at least this knight here is protected by the queen. So at least the king will not capture this knight. So now I will show you a typical checkmate situation in Niel's chess. So now the rook will give a checkmate by going into superposition. And by the way, when you go to superposition, you can only go to unoccupied squares, okay? You cannot try to capture anything during the superposition move. Okay, so here the rook went into superposition, and now the king is at risk of being captured. So this is a check. And for black here, there is no move which would lead out of this check, and that's why it is called checkmate. So this is a typical checkmate situation in Niel's chess. When you cannot go out of check, it's a checkmate. So here is another one with the queen. So here I will just illustrate that that you can do that a superposition by staying where you are and moving at the same time. So the queen stayed where it is and moved at the same time. So this is also now a check, because the king is under risk of being captured. And now the king cannot move out of this check. But here you may think that, okay, but what about if the king tries to capture this queen? What happens then? So what happens is that the queen would collapse now because it is disturbed. So now it would collapse. So we would have to roll the dice. But when we roll the dice, there is a 50% chance that the queen would actually collapse here on the square with the blue mark on it. And then the king would remain in check. And that's why this move is just not allowed. Because in Niel's chess, if a move potentially leaves your king in check, then it is not allowed. It is similar to normal chess that you cannot make a move which would leave your king in check. And the same here, you cannot make a move which would potentially leave your king in check. So this move is not allowed, as I said. So this situation here is really a checkmate, because black cannot do anything which would get it out of check with certainty. So it's all about risk management, little bit. So now comes the most complicated rule of the game. So listen carefully. I don't know, somebody should mute, because somebody says some audio interference. It is not.
Niel, I think we can hear some
Not here.
Can you,
Okay, now it's good. Now it's
stop
good.
while there's background noise? Thank you.
Okay, good. Oh, now it's back.
Okay, someone is doing some background noise here.
Yeah.
I might be able to find out who it is and mute him.
Okay.
Okay. Okay. So okay. So here comes the most complicated. I mean, it doesn't disturb me too much, but I can imagine that if you want to concentrate and you don't yet know the rules, it can be disturbing. Yeah. Okay. So I will explain now entanglement. So this is the most complicated part of the game. So now basically the knight is already in superposition, and now the bishop can entangle with this knight. However, if the bishop wants to entangle, then it has to be close, or it has to move close to the knight, meaning, for example, here that close means that it is in an attacking position. And the rule is that if the bishop now wants to entangle, then it can do it by staying where it is and moving at the same time. So now watch it carefully what happens. So now the bishop is entangled with the knight, and entanglement is indicated by the marks being aligned on the same diagonal. Okay, so here you can see that the marks of the bishop and the knight, they are aligned very nicely along the same diagonal, and this means that if you have such pieces on the chessboard that the marks are along the same diagonal, then they are entangled. So, and entanglement you can make, for example, here is a piece, and all you have to do is to basically rotate it on the chessboard by 45 degrees. Okay, so what does entanglement mean in practice? So it means, for example, when the knight tries to capture the pawn, now again it hit the pawn, so it gets disturbed, so the knight will collapse, but now the knight is entangled with the bishop, and that's why they will collapse together. They will collapse together, and the collapse is random. So let's roll the dice. A 4. So 4 means 4 is an even number. It means red. So both the knight and the bishop will collapse on the square with the red mark on it. So let's see, collapsed, and now the pawn escaped. So this is the entanglement. So I can see some questions on the chat. Yes, that's right. So in the example with the queens and checkmate, there is only a 50% chance that there is an actual checkmate, right? Yes, it is right. I mean, there is a 50% chance that in a hypothetical next move, the king would be captured. But this means that the king is at risk. And in Niel's chess, the check means that the king is at risk of being captured. And the king has to avoid such situations. And if it cannot avoid the situation in the next move, then it's a checkmate. So you can memorize like this that there is a check, and if the king cannot get out of it, then it's a checkmate. Okay, so this is entanglement. And don't worry, you will see many examples later. Okay, maybe not too many for entanglement, but for check and checkmate, you will see many examples. So and the last rule is the tunneling. Sorry. There is one more situation I forgot. So entanglement can give rise to interesting situations which look a bit weird for a conventional chess player. So, for example, here this is a check because the king is at risk of being captured. So now the king can get out of this check in a weird way. So because now it is close. It is close to the queen. It's already in attacking position. And then, it can escape by entangling with the queen. So this means that, this is not a check. And this is not a check because the king has zero risk of being captured. Because if you think about it, if we try, let's say the queen tries to capture in a hypothetical next move, and then what will happen is that both of them will collapse because now they disturb each other. Both of them will collapse, but they are entangled, which means that they will collapse either both to red or both to blue. However, a capture can only succeed when they both collapse onto the same square. But here it is impossible because one is blue, the other is red. So they will surely not collapse onto the same square. So the king cannot be captured by this move. And that's why the situation was not a check, because the king has no immediate risk of being captured. So this is a weird situation, and actually I realized it pretty late after I established the rules, and then it took a couple of weeks to realize that such a situation can exist. Okay, so now to tunneling. So quantum tunneling is when an object like a, okay, let's say an analogy like a tennis ball, there is a barrier like a wall, and you are throwing the tennis ball against the wall, and then there is a small probability that the ball will actually end up on the other side of the wall. Or if you want to do it with particles, that there is a particle and there is a barrier, and the particle doesn't have enough energy to pass the barrier, but then there is a very, very small chance that when the particle goes against this barrier, that it will somehow end up on the other side. So this is referred to here. So now the rook wants to give a check to the white king, and then so it indicates that it would like to tunnel through the pawn. So tunneling can only be done with classical pieces, okay? So that not to overcomplicate things. So now the rook indicates that, okay, I would like to tunnel through right behind the pawn. It cannot tunnel here or here because this is too far away, and the probability of tunneling, as far as I know, it decays exponentially after the barrier. So it can only tunnel to the square right behind the pawn, okay? But it has to be lucky. So we roll the dice, and here we roll the 6. Now if we roll a 6, then yes, it can tunnel, great. However, if we roll another number, 1 to 5, then the rook would have basically bounced back and just stayed where it was. So it's a very small probability event, but if you are lucky, then you can tunnel through, and sometimes you can cause some problems for the opponent. So these were the rules. So I don't know, do you have any questions so far? Feel free to unmute yourself or just write in the chat.
I'm just speaking for myself. I may need to be reminded of the rules as you go along with the examples. I'm already confused by chess, classical chess sometimes. So
Okay.
Just beware.
Okay, no problem.
I don't know if everybody else feels that way, but yeah.
Okay. So don't worry. I just when anything is unclear in the puzzles or the examples, just let me know, and yeah, I will try to shed light on it as much as I can. Okay, so how to play? So now this quantum chess or this Niel's chess is something new. It requires a different way of thinking. So honestly, the answer is I don't know how to play it, because it is also new to me. I am also a beginner. But what I would recommend is that you play it in a way that you start playing just normal chess, and then you wait for the opportunity when the superposition move can yield you any benefit, and then you just do it.
Tamás, we have a comment in the chat. Can you see it from Alex?
Yes, you just wanted to react. So the superposition rule and the first situation you showed seems to be super imbalanced. The player who used it in that situation got a very big advantage without any drawbacks. Yes, I mean, I don't know, but my argument would be that the opponent also has the chance. So they both start out in the normal initial chess position, and the other player also has the chance to go into superposition. So if the player doesn't want to get drawbacked, then just build up the situation in a way that the opponent cannot cannot make such a move to his or her advantage. Yeah.
Alex, does that address your concern?
Okay, so there is another question. So do you choose whether, fair enough, okay, thank you. And by the way, so this is to Alex. So this is a traditional board game. So you can make this at home, these pieces with the marks. And if you don't like a rule, or you have a better idea, or you want to try something, feel free to do it. So the rule is that if you don't like a rule, then just change it. Feel free to change it.
So we have another question from Dave.
Yes. So do you choose whether to superpose, tunnel, or maybe even go with a traditional move, or is the latter not allowed in Niel's chess? So in Niel's chess, everything is allowed, and you choose freely what you want to do. You can, if you choose to superpose, you can choose to entangle, you can choose to tunnel, or you can choose to make a conventional move, whatever you want. There is no restriction there. The only restriction is that you shouldn't put your own king into check. Okay, so how to play? So here is an example. So this is a famous game from 2004, Magnus Carlsen versus Sipke Ernst. And this game goes by the name the Magnus effect, because it was one of the most beautiful games played by Carlsen. However, in this example, we will only play it up to 5 moves, and it will suddenly finish. So if it had been a quantum chess game, it wouldn't have been famous at all. So we start from the normal chess initial position. So this is what Carlsen did. And then, so the game went by like this. This, and this. And now white has the move, and here is the chance. So here is the chance to make a superposition move and end the game. Because now, if we make a superposition move like this is a checkmate. Based on the rules that I told you before, this is a checkmate. Because here, so now the king is obviously under risk of being captured from actually 2 sides. And then black really cannot do anything, because if you think about it, let's try to capture this knight here, for example, with this pawn. Let's try to capture it. But the problem is that if we do that, if we try to capture it like this, something like this, then the knight would collapse, and there is a 50% chance that it would actually collapse here on the square with the red mark on it. And then that would potentially leave the king in check. So this move by black is not allowed. Cannot do this. Cannot do this. And then it is true for anything. So if you try to capture with anything else, so yeah, so entangle and capture, it's on the chat. So basically, the rule is that when you entangle or when you go to superposition, you can only move to unoccupied squares. So it is not allowed that this pawn entangles with the knight and then comes here and here at the same time, attacking it. Okay, so this is not allowed, but it can be a variant of Niel's chess where this is allowed. And actually, in the very first version of the game, like a year ago or so, this was still allowed. But then I just realized that the problem is that if I allow this, that I can capture during an entanglement move or during a superposition move, then it will collapse the evolving superposition immediately. And this is what I wanted to avoid, because once there is a superposition, I just want to keep it on the chessboard. So I don't want to collapse it immediately. And that's why when you do superposition or entanglement, the rule is now that you can only do it if you move to unoccupied squares. Yeah, so again on the chat, so very similar situation as before, huge advantage for the player who uses it and no reasonable defense equivalent action. Yeah, but my answer would be the same, that yeah, it is so black can tank it to himself. that it got into such a situation. And actually, another answer would be that I still don't know what kind of patterns this game would unearth, kind of, and maybe this game can be played in a way that the one who goes into superposition, so somehow black can defend efficiently, and then there will be no such imbalance, as you say. But now, according to the current rule, this is a checkmate, and the king cannot even escape by entangling with the knight, because if it moves close, so if it stays here and moves here, the king, and entangles, it cannot entangle in a way that it will not get into check again, because this knight here with the blue mark, the problem is that this attacks both squares, attacks here e8 and attacks here d7. So if the king goes into entanglement with the knight, then one of the indefinite pieces will be blue. So either here or here will be blue. So which means that it will stay in check. And that's why the king cannot really entangle. So this is really a checkmate. But later there will be simple puzzles that you will understand this better. I think you have to allow superposition, but for multiple pieces.
There's a question right above that.
Okay, so the quantum game of chess decays into multiple concurrent boards, and it is not clear how to decide who is the winner. Oh, I mean, there is a quantum chess variant, not Niel's chess, but a different, where it is really multiple boards. But here it is not multiple boards. Basically, here it's a different philosophy. So here you can decide who the winner is easily. Yeah, it is just a different philosophy. Here it is not chessboards in superposition, but it is individual pieces in superposition, basically. Yeah. Okay. But what does it mean? Do you have to allow the superposition, but for multiple pieces? What do you mean by that?
Does it mean multiple pieces in superposition at once? Alex,
Or maybe it's
do you want to unmute yourself?
It is like e7 to g6 and like e7 or whatever. I mean, you have to counter this somehow. Like there is, it's good to define some rules for like any game in any way, but in the end, like there has to be some reasonable, middle ground. The game should be balanced. There is no sense in playing a game which is not fun and which is not balanced.
Okay. Yeah. I don't know.
From what I understand, the game is balanced because either player can use these tricks of superposition and so on.
Well, by balance, I mean in chess, like it's with classical chess, it's a perfect example of balance when you can make mirror moves, etc., etc. And like, yeah, if you capture like other players' pieces, it's about your skill. But here you introduce some actions which, like, if you can if you know how the position, the worth of position is calculated in classic chess, they have things like +1, +2, +10, whatever. So here you introduce some like new moves, which by your rules are okay, but it like messes up, a classical way of thinking, like what is the advantage and how to win the game.
Yeah. Okay. So okay. So I think it's. I mean, this is one of the intentions, that it has to mess it up. But maybe, what do you think about this? So I will show you a situation. So it's because I have something I want to ask your opinion. I call it slow down. So here, you remember the situation from before that we can give a checkmate by having the rook move here and here at the same time. So superposition move and then immediate checkmate. That the rook moves to c8 and g5 at the same time. Now, if you find it too fast, then maybe you would find it more balanced if we don't allow it. If we just have a variant of the chess where we only allow a superposition move that one has to stay, and then basically this stays and moves at the same time. And now the king has to escape, and only then it's a checkmate. And this way it would be slower. I don't know if you would say that this is more balanced than that, if we can just give a checkmate immediately by moving here and here at the same time, if we just do it slowly. Because then black has more chance to react, basically. Yeah.
Alex, what do you think?
So like if you can go back to the very first example, just for the sake of like
The very first other superposition, you mean?
yes.
Okay.
Yeah. So in this case, like if you evaluate the original position of the board, as far as I understand, black have like huge advantage compared to white. Like black is almost guaranteed to win in the original classical chess position.
Yes.
And here with a single like what is it, like horse, you basically like turn everything on its head.
Yeah, but black has to assist to this, because so even in conventional chess, if you have this situation, then yes, black has chance to win. But if black makes a stupid mistake and moves with the rook accidentally here, then it will lose the advantage. And also here, so in Niel's chess, black made a mistake because this is a situation which white can exploit. So black made a mistake here, clearly. So black shouldn't be in this position at all, because it should know that this might happen.
Can I suggest that we postpone the rest of this discussion for after you're finished with your presentation?
Okay, we can take it offline.
Well, not offline necessarily, but we can just
Yeah, sure.
get done with it.
Okay, yeah. But on the other hand, yeah, feel free to think about rules which make it more balanced. Yeah. Okay, so there was some other question on the chat. An improvement might be having a limited number of superpositions per game. Also avoids too much thinking and dice rolling. Yeah, that can be also, but here I don't have any limitations. You can put every single piece into superposition if you want. And letting players be more strategic about superposition instead of using it all the time. So now this actually happens with the entanglement, because with entanglement, I told you that the marks have to align along a diagonal. Now, there can be a group of pieces whose marks are aligned along one diagonal, and there can be another group of pieces whose marks are aligned along the other diagonal, because there are two diagonals of the square. So there can only be maximum two entangled groups of pieces. And then if both of the diagonals are already occupied, then you cannot create more entanglement. So actually the number of entanglement groups, kind of, that's already limited, but the superposition is not limited. And this is basically inspired by having this thing in quantum information, that entanglement is a resource. So it has to be limited for the players, kind of. But superposition is not that much of a resource, so it is kind of unlimited in this game. Okay, so then Pauli exclusion principle for some combinations. Yeah, absolutely. So if you are an educator and if you want to demonstrate some quantum effect, including the Pauli exclusion principle, then you can then feel free to invent some new rules, and then in the classroom you can show on the chessboard what a Pauli exclusion principle means. Okay, so now let's go to the puzzles. So first, I will show you 8 puzzles on a small chessboard. So these will basically cover some of the common patterns of the game, common patterns which I have already discovered. So let's start with this. This is a very easy one. So here, white has the move, and it's a checkmate in one move. So white has the move. So what is that move? So now it has to be somehow interactive. So if anybody has an idea, let me know or type on the chat, in the chat. But it is better if somebody just says it. This is easy, actually, here.
Anybody have it?
Okay, so is this one countered with that what was it, the entanglement?
This one, so here white can just give a checkmate with a simple superposition move. There is no here.
Okay. After that, can we do the superposition of the king like with the opposite, you know, like with the opposite move?
No, we cannot, because okay, I'll show you the solution. Okay, so this is the solution, and now the question is whether the king can entangle afterward. We cannot entangle because it is too far away. So to entangle, you have to be close, and this is also inspired by quantum experiment. When you want to entangle to atoms or ions, whatever, then you have to bring them close. But anyway.
Okay, can king move, like do the superposition, like red goes to e5 and blue goes to d6? If we can do that, then it's not an issue. But
So,
if we can't, then it might be kind of problematic, because like what's the point?
Yeah, so it is not allowed, because imagine that you have done that. So here is, let's say here is the blue, here is the red king, right? So the blue mark, red mark. But then the problem is that this is still a check, because the king is still, even after this superposition move, the king would be still at risk of being captured. Because now if we imagine the king is here and here, I just make it like this. I don't do the marking, but imagine that this is superposition. And now what I do, for example, with this rook, I will try to capture the king, and then both of them will collapse. And there is a 25% chance that both of them will collapse here on this square.
No.
Right?
Just 50% chance. Red collapses to red, blue collapses to blue.
No, this is not entangled. So you cannot entangle your king with the rook because it is too far away. It is not in an attacking position. Okay, so the king cannot entangle with the rook because it is too far away. So here the king can
okay, fair enough. Okay.
Yeah, it can only go into an independent superposition, and then you have a 25% chance. So it is still a check because it's a non-zero chance that the king gets captured. So this move would not be allowed. So the king really cannot do anything. It's a checkmate. Okay, so let me on the chat. I like this because the rules of quantum mechanics are so counterintuitive to classical physics. Playing a game like this helps to immerse in quantum mechanics rules, so they become more intuitive. Was that the purpose? Hope? Yes, exactly. This was the purpose. So it's basically originally I created this game because my idea was that I would give courses to IT professionals. And then when I first heard about some other variant of quantum chess, I got very excited. But then I realized that even I don't really understand those rules. And that gave me the idea to invent something which is simpler, which even children can understand. It is difficult to play at the beginning, at least, but at least everybody can understand these moves, and that was the motivation. Okay, so let's go to the second. Yeah.
So, sorry, maybe one additional comment. So I think the issue with the rules, like as you presented right now, like, okay, the checkmate is when, you know, the check is when, like you are threatened, like when there is a chance,
yes,
that like, you know, your king will be like attacked, and the issue I can see is that by doing these, you know, for example, whatever entanglement or whatever superposition, you multiply those chances, and it can't, like, you have to pay something for it. It can be done for free.
yes.
That's
So,
my point.
Yeah, and actually, so my solution to this was that that I don't allow multiplying more than down to 0.25. So for example, this rook, you cannot go further into superposition, that you move like with this blue one, like here and here at the same time, and then it will be, and then the amplitudes get smaller and smaller. So basically, with these rules, which I specified, when the king is at risk, at a non-zero risk, it is always at least 0.25, probability of 0.25. So I think this is kind of fair enough to call it the real danger. Yeah. Yeah. Okay. So let's go to the second puzzle. So here, so black has the move, and it is a checkmate in one move. So what do you think the solution is? So black has to checkmate.
So I have an idea, but I'm not.
Yeah. Yeah. And the idea?
Yeah. Oh, it's in the chat.
C2. Yeah, but do you mean just a classical move to C2, or?
Oh, Mark, what did you?
No, because then the king can come here. So if the knight moves here, then the king can escape here. So if the knight comes here, then the king comes here. So so it is not, but almost. You are almost there. So obviously it has to be superposition, because otherwise it wouldn't be in this talk. Yes, so you have to make a superposition basically, but in a way that you stay and move at the same time. So like this. And here, yeah, because now the king cannot come here anymore, because then it would be in check by the blue knight, kind of. Yeah. So this is the checkmate. Yeah. So because now the king is at risk by the red mark knight, and then if it comes, it cannot entangle because it's too far away, and if it comes here, it will be in check by the knight with the blue mark. So this is really a checkmate. The white cannot do anything here.
I think you should prohibit the like missed you know, turns.
Why?
You shouldn't allow like pieces to stay where they are.
Yes, I mean I can tell you again that in the first version it was like that, but yeah, I just decided for these rules, and but there can be infinitely many variants of these rules, really. And yeah, it was just basically my taste that I thought it's a good idea if I allow that it stays here and moves at the same time. Yeah. But yes, I do expect that many people would have different ideas about the rules, but they are all free to make any rules they want, because it is a traditional board game.
That's fair. That's fair. I mean, my point, like, once again, going back to the notion of balance, at least some sort of. Once again, it seems like if you know, leave the piece where it is and gain a new like partial position for free, it's kind of, you know, not very balanced.
Yeah, and I mean, this is true, but you say if we talk about check, right? Because if it is not about check, then it is kind of balanced, because it is only like you can say like not fully here and not fully here. So then if you want to like attack some other opponent piece, then you will also have some risk that your attack will fail. However, with the check, it's a bit of a different story, because for the check, it's enough if you just have a 50 or 25% chance of capture. So in this sense, yes, we can call it imbalanced, but the truth is that I don't have a better idea.
So in this puzzle, it would be white's move. Why can't the white knight take the red knight?
You mean the
Why
white
can't-
knight?
Or oh no, never mind.
No,
It can't. Okay, never mind.
Yeah. Okay. So okay, one question: do you think knights are more powerful than bishops in Niel's chess? Yeah, actually, I was thinking about the same, because I can imagine such imbalances more with knights than with bishops. So yes, I would guess that the knights become more valuable in Niel's chess, but I'm not sure. It is just my initial guess. Okay, so let's go to number 3. So now it's white. So white checkmates black in one move. So obviously the white king has, the queen has to move, and it's checkmate in one move. So what is that move? Can you guess?
Once again, it's easy for me to think classically, and I know that's got to be wrong.
Okay, and what would be your solution?
Queen to c6 and e4, or I mean e3.
EC and C6.
Yeah.
But that is the problem is that then with this queen, you can come here, and then so basically let me just do it. And then with this queen, if you come here, then either you will capture it or it will collapse here, and it will not be a check anymore. So you can defend it if you do that, but it's almost the solution, almost. So you basically have to block this queen. You have to block the black queen from interfering. Yes, that's the solution on the chat from Mark. And so this is the solution, superposition. And now, so this is a check, obviously, the king is in danger. And now with the black queen, you cannot do much, because if you try to capture the white queen, then it will collapse. And there is a 50% chance that it would end up collapsing here to E3. And then it would leave the king in check. So if you try to capture with the black queen, then potentially it will leave your king in check. So you cannot do that. It is not allowed. So black really cannot do anything here, and cannot even entangle because it's too far away.
Can the black queen tunnel?
No, because it's even probabilistic, because there is a chance that, okay, first of all, you can only tunnel right behind. And second, you can only tunnel through another classical piece. You cannot tunnel through a piece in superposition, or through an indefinite piece. And third, even if you could tunnel, there is a big chance that the tunneling will fail and the situation will remain as is, and you would leave your king in check. So tunneling doesn't work for at least 3 reasons here. And the fourth reason is that when you tunnel, you can only tunnel to unoccupied square. So it would not attempt to capture at all. Yeah, so the danger.
Okay. I think I came up with a proper articulation of what I'm trying to say. When you are using these tricks, basically you create an additional free move, while the opposite player does not. I think like to make the game balanced or something, you have to compensate it somehow. Because here in this example and in previous ones, yeah, like you're creating two, like black cannot respond in one move.
Yeah. So yes. Okay. So here maybe I can argue that there must be some incentive to make a quantum move. We can call it quantum advantage on the chessboard. And then yeah, we can think about it like this, that if you do some quantum effects, then it can really be to your advantage, because otherwise the whole quantum industry wouldn't exist. Yeah, and then this can be one argument. And then because if it was balanced like you wish, then people would be really discouraged of making quantum moves. But that said, I am pretty sure that these rules will evolve with time. And then if there are too many people who think that it is just too much advantage to make the quantum moves, I am pretty sure that the rules will be somehow changed. I don't know how, but maybe somehow they will be changed. But right now, I think, yeah, I think it's kind of reasonable to give this advantage, and also saying that it is black's fault because black shouldn't have gotten into this position in the first place. Okay. So now let's go to number 4 puzzle. So here, this is also, and here actually you can see that being a superposition can be a disadvantage. And actually, I could show you other examples that being in a superposition can be later a disadvantage, but I think this is the only example. There will be maybe one more. So here, black has the move, and it's checkmate in one move.
A6
Exactly.
to A2.
Yes, exactly. So this is even a classical move. So this is because then the king cannot do anything, because if you try to escape with the king with the blue mark, you escape, for example, here to C3, but then the king will still be in danger, because then the rook will attack the king on E2, and it will still be a check. So this is a checkmate. And now let's see another one. So this is similar to the previous one, but it's a bit more pieces. So here is the same. So black can give a checkmate in one move. So what should be that move? What do you think? So this is here the white king.
Looks like the same as the last one, but why isn't it?
Sorry?
Looks like the same move as the last puzzle.
But then the problem is that if you move the rook here, then the queen moves here, and it is blocking. So
oh, that's the white queen. Okay.
Yeah. Sorry for that. It is the white queen, yes. So on the chat, somebody says, perhaps superposing the king is never advantageous. Yes, I would agree with this. Yes, that it is only when you want to escape a checkmate, as we will see later, and you choose to entangle the king, but only to avoid checkmate. And then it can be advantageous for the short term, but if your king is in superposition, then it's super dangerous that you get a checkmate easily. Okay, so
we do a super on the rook to A2 in C6.
Okay, so this is what I think most people would do, but then Ansha says D3, and actually that will be the solution. So, but I have this, so this is what most people would say. But here the problem is that there is the white queen, and we can block it. We can just do this, and then the check is blocked. And now this is not a check anymore, because we can also use superposition for defense, actually. Okay, so what is the solution? It is what Ansha said, that let's go back. So the solution, and sorry for misleading you a bit with the previous puzzle, the solution is this, simply. Because here, this is a checkmate, because the king obviously is in danger. And then now, whatever the king does, so the king cannot just move away with this here, because then it will still stay in check. The king cannot try to capture the pawn, because then the king will collapse, and it might collapse actually here on c2, and it will remain in check. So white really cannot do anything here. So white doesn't have a move which 100% guarantees to eliminate the risk of the king being captured, or 100% guarantees to eliminate the check. So this is a checkmate here.
So a question, once again, sometimes you generate like 2 moves instead of 1. Here you have kind of half a move in a sense. Like, do you think it's worse to introduce something like, okay, I can move like both of the pieces? Both of the like superposed pieces?
Yeah, so yes, I mean, it is true that in quantum mechanics, if you have a system in superposition and you do an operation, then because of the superposition principle, then both branches will kind of move, kind of affected. But I thought it would be too complicated. So if, for example, I say here that, okay, with the king, I move 1 to the left, and then it would actually move both kings 1 to the left, and this would avoid the checkmate. But I think if I introduce such a rule, it would be too complicated for mortals like myself. So it would make it super complicated to think about such situations. Yeah, if this was your question, you could introduce it, but I wouldn't.
Okay, sure, thanks.
Because here, at least you will keep the characteristic of a classical chess in a way that you take a piece, let it be indefinite piece or normal piece, just take a piece and move as according to the rules of classical chess. So you grab one piece and move it, and this is what a classical chess does. And even when you go into superposition, you kind of grab one piece and just move it to 2 places, but you always grab one piece and not 2. Okay. So actually, it is here what I was talking about. This is not allowed because the king might collapse to c2, and then the check would remain. So this is not allowed. Okay, so here is one. So here black gives a checkmate, but only with 50% probability, only with 50% chance. So what should black do so that it's a checkmate with a 50% chance?
I'm sorry, one additional comment based on previous example.
Yeah.
Maybe like one of the modification could be like, so in this case, white like e2 tries to capture d3.
Yeah.
If it succeeds, like if the like, you know, you get your dice roll like properly, then it collapses and everything okay. And if it doesn't, maybe you should give additional move to the other player.
Yeah, I don't know. I mean, I would feel, if this was the rule, I would feel that it goes too far away from the chess that I know. Yeah.
Okay.
I mean it because okay, it's subjective, but I want to feel that I am still playing chess. Yeah. although with those imbalanced quantum rules, yes. But still, I just want to have the feeling as much as possible that I am playing that it's like an extension of the characteristics of chess. Okay, so here black has the move, and so black moves something, one move, and it will result in a checkmate with a 50% chance. So what should be that move?
So it's black's move. Is it?
Yes. Obviously, the knight has to collapse. I mean, it is obvious to me, of course.
Yeah, I'm completely stumped.
Of course, I mean, half a year ago, this was not obvious to me either. So somebody should really know this. There are basically two possibilities to make the knight collapsed. Exactly.
So that pawn takes blue knight.
Exactly. That's the solution. It's also on the chat. So this is the solution. So because now the knight will collapse, and then there's a 50% chance that the capture succeeds. And when it succeeds, it will be a checkmate. I show you. It collapses here. There's a 50% chance that this happens. And now it collapses to the same square as the pawn is. So the knight is captured now. And this is a checkmate. So now the white king cannot do anything. It's even a classical checkmate now. Okay, so this was number 6. 2 more to go. So here, this is with entanglement. And now, yeah. So black has the move. And so as you can see, the rook is entangled with the bishop. So now black has the move, and it's checkmate in one move. I mean, 100% sure checkmate in one move. What should be that move from black?
This is the first slide that we've seen where there are two superpositions at once.
Yeah, this is the
Are there
first.
2 entanglements too?
This is entanglement. So because they are aligned.
Oh, there are 2 entanglements, yes.
Yeah, they are aligned along the diagonal. I mean, it is one entanglement. I mean, two pieces are entangled. So the bishop is in. So this is one bishop. This is one bishop, and this is one rook. Okay, and the rook and the bishop are in a spatial entangled position. So obviously it has to collapse. So basically, the bishop has to make a move, bumping into the rook. But which bishop? Because if they bump into each other, they will collapse both. I mean, they will collapse.
I would say red bishop takes red rook.
Exactly. That looks like a white bishop. Sorry for that. I just wanted to indicate that it's not a classical one, so it's a bit lighter. Yes. Okay. So yes, this is the solution, because then now we will have to roll the dice, and then there's a 50% chance that both of them will collapse on C3, because both of them onto the square with the red, and there is a 50% chance that both of them would collapse to blue. And now, if you think about it, if they both collapse to C2, then the rook is captured, is taken, and then the bishop will stay here, and it's a check by the bishop. and it's a checkmate, a classical checkmate, because the king cannot do anything, because the king cannot come here because the pawn is here. But now I will show you the other option, that with 50% chance they will collapse to the blue square, and that's also a checkmate. So whatever happens, it's a checkmate. So let's see. Now they will both collapse to blue. Okay, sorry, we even roll the dice. It's a 3, so it's an odd number. So this means that they will both collapse to blue. And this is the situation after the collapse, and this is a checkmate because this is here a check, and white cannot do anything against it. So this is a classical checkmate even. Okay, so let's go to the next one. So here is, okay, so now this looks like a dangerous situation for black, and the question is, so it's a check by the rook. How can the king escape this this check? So how can the king get out of check? What do you think?
Can the queen take?
The queen cannot take it because then the rook would collapse, and there is a 50% chance that it would collapse here, leaving the king in check. So this move is not allowed because potentially it can end up in the black king being in check. So the queen cannot really interfere here.
What if the king moves leftward?
The king does what?
What if the king moves to d6?
You mean classically? Or entangling?
For entangling, or
yeah, that can be a solution, yes. Because if it moved to d6, so stay on e6 and move to d6 at the same time, then it gets close. It gets close to the rook, and then it can entangle. And then here would be blue on d6, and on e6 it would be red, and that would basically escape. But I show you another solution which is similar, but the king, let's say the king moves here. This is what I prepared, but your solution was also good. and then so the king can just entangle like this, and now you can see very nicely that the red rook attacks the blue king only, so it can't really capture because they are entangled. So it either both collapses to blue or both to red, and similarly the rook with the blue mark attacks the king with the red mark. So this rook also has no chance to capture the king in a hypothetical next move. So this is not a check anymore. Okay, so this way the king, at least temporarily, escapes, because the rook has 0 chance to actually capture the king in the next move. So this is how entanglement can be used to get out of check. But of course, now the situation is super dangerous because now the king is in a superposition, which is actually shared by the rook. But still, this is not a very advantageous situation for black. But there was no other choice. It had to do something like this.
It only delays the inevitable by 1 move, though, right?
Yeah, because I think
Queen to b3.
Or so this is the black queen. So now it is white move, and now I think if it moves here, so this is red. So if it moves here, I think this would be a checkmate, because now the king is at risk, because now this red attacks the other red. So if it tries to capture, then there is a chance that they would collapse on the same square. And now I think actually no, it is not true, because now what the king can do is that okay, it can delay a bit more because it can just move away here, and then it is still out. So they can play for a couple of moves more, but actually then the rook can come here. Oh, sorry. Okay, just a moment. So the rook, if then comes here, I think yeah, even this is not a checkmate, but I don't want to overcomplicate because now the king can try to capture the rook, and then they will collapse, and then it will not be a checkmate, a check anymore. But anyway, this is just you can think about it at home, but the point is that by entangling, the king can really get out of check, and it can delay the inevitable. Yes. Okay, so these were the puzzles. So now I want to show you two real games, historic games, where we can apply some simple quantum move to achieve checkmate, and we achieve those checkmate kind of even before the game would normally end, historically at least. So the first game I want to show you, it was played, it's a Fischer game, Bobby Fischer. It is called the game of the century, played in 1956. And we will go to step 20. And now Fischer will have the move. So Fischer is black. So here it is. Here is the situation. So Fischer is black. And yeah, Fischer has a good position here. And now the question is that, okay, now Fischer has the move. So black has the move. And it's a checkmate in two moves. So in two moves, it's a guaranteed checkmate. And I can help you that the first move is classical, and only the second move is a superposition move. So now the question is, what should be the first move by black? What do you think?
I'd just like to point out that in junior high school, I came in 12th in a chess tournament in which there were 12 people. So I wouldn't even be able to solve this in classical chess, let alone.
No, in classical chess, this game went on by 20 or 25 additional moves. But here in quantum chess, we can finish it in two moves. So maybe the quantum rules can actually make the chess games shorter, which is not a drawback in today's world when nobody has time to play for 2 hours.
I'm a lousy chess player, so I'm just kind of staring at this.
Same here, but I already thought about this. That's why I have advantage here. So now, okay. So any guess?
I would start with an E2 to C3.
E to C3. Yeah, that is not the solution. That is not my solution. I wouldn't know how to finish it. Yeah, so if you do that, wait a moment. So if you do that, it's a check. Then the king has to move, right? So there is no chance, cannot prevent. So the king then has to move here. And then what would you do next? What would be, now you should give a checkmate in one move. What would be that move?
And you were suggesting it would be a superposition.
Yeah, and now obviously you can only give a check, okay, with the rook, but then it would be taken immediately. Or you can give a check with the knight, but then the king can just move back here if you do that, because then the knight would cover the bishop. So it wouldn't be a checkmate in just one additional move. But it is right that you have to move with the knight. So just in the interest of time, I think I just show you. So the first move is this, and now I ask you again. So okay, now this is the move, and now the king has only one choice. It can only do one kind of move. So it can only move here, no other possibility. And now it's checkmate in one move. So what would be that one move, one superposition move that would make a checkmate here? Pawn takes, so wait. So the king was here. So the pawn cannot take the knight because the bishop is also giving a check here.
Yeah.
Is it knight goes back and stays in the same place?
Yes, so actually that was my solution first, but then I realized that if we do that, so knight stays here and comes here, then the king can entangle, like for example, let's assume this is the blue knight, this is the red knight, and then the king stays here blue and here red, entangling with the knight, and then it would at least delay the checkmate, because then it can get out of check. So the solution is a bit more weird. If anybody has other idea.
Okay, this is a wild ass guess, but super the bishop at c4 to e2 and f1.
But there is no check then. So if the bishop comes here, and,
Yeah.
there is no check. So anybody else? It has to be the knight, I can tell you. It is the knight, but in a pretty weird way. I think I will show you. It's actually pretty weird. This is the solution. So now the knight goes to superposition, and you can see that it's obviously a check, because the red knight is threatening the king. And but why is the blue knight here? It is here because then, so what the king can do, okay, you may think you can try to capture it with the rook, but you cannot do that because it might collapse here to the red, and then it would remain a check. So you cannot do this with the rook. And now you might think, okay, the king may try to capture this knight, but now, of course, now the problem is that there is a 50% chance that the king will actually succeed, that the knight would really collapse here to f1, and the king will really capture it, but then it would open up this corridor for the bishops, so it would result in a check. So then the white king would be in check. So white king cannot try to attempt to capture the knight, because then it might end up in a check. So this move is not allowed. Sorry. So the white king basically cannot do anything here, and this is a checkmate. So this is the solution here. Okay, so now the last game, or do we have any question here? I guess not. Yeah, thank you. Somebody says nice. Okay, so the next game is also a famous game, Kasparov versus Topalov in 1999. And it's the name of the game is Kasparov's Immortal, because Kasparov won the game, and it was a very, very famous game, with very unusual gameplay, I think. So if we go to the game in move 29, so it will be Kasparov's move, and the game went further for I don't know, like 20 more moves, but we will finish it here in just one move. So this is the situation now. So Kasparov is white, and now it's white's turn. And now white gives a checkmate in one move. So this must be easy. So one move, checkmate. So any idea? Obviously, you to give a checkmate, you have to give a check. And there are not many possibilities that you can give a check here.
So super d5 to b3.
Wait. White has to
Oh,
go. So,
white's move.
yeah, white.
Too many variables in this game.
So there is only one way to give a check, basically. But then the question is how to ensure that it's a checkmate. Yeah, it is White's move. So Mark says superposition B3, C7. So actually, if you do that, okay, first of all, B7 is not needed because the king cannot come here because the pawn is here. The white pawn is here. The king cannot move here anyway. And then the other thing is that if you get your queen here, then the black queen can just attempt to capture it, and then either it collapses here and gets captured, or collapses here, but in any way, it will be not a check anymore. But it is almost the solution that you say. C3, C5, this. So almost. You are almost there, very close, very close. So obviously you have to get your queen here to give the check, but then what else should you do in the superposition?
Leave it where it is?
Yes, but the problem is that if you do that, let's imagine that now this is a superposition, then again the black queen will come here and try to capture, and the black queen would surely stay here, and either it will capture the queen, or the white queen will collapse here, so it will be no check anymore. So yeah, on the chat I can see the solution. Yeah, so yes, pawn protects queen, king can't move right. Okay, so the solution is already on the chat. So c4 to block, that's the solution. So here it is. So basically this is obviously now a check, so the king is threatened. And now the black queen cannot do anything, because if it tries to capture the red queen, then the queen might collapse here to b3, and then the king remains in check. So potentially the king will be left in check. So the queen cannot do this. This is not allowed, because then it would leave the king potentially in check. So this is the solution here. And so I think it's there was a puzzle before which was similar, where you used one queen in the superposition to actually deliver the check, and you use the other queen in the I mean, it is the same queen, but you use the other indefinite piece to actually block black from interfering. So this was the second game, and actually just let's continue with the next move, because this was not a quantum chess game. So what Kasparov did was this. You see the rook. Kasparov did actually this, and now, okay, this is the last puzzle for you. Now Topalov, so black, has the chance to give a checkmate in 2 moves. And again, okay, there are 2 solutions here at least, but I want to hear the simplest solution. And the simplest solution, the first move is a classical move, and the second move is a superposition move. So what should be black's classical move to finish the game in 2 moves? So what should be the classical move by black? Not many possibilities. Exactly. So on the chat, it says queen to d1. Let's do that. Yes, this is the first move. And now the king has to escape. So let's say, actually, it doesn't matter whether the king goes to b2 or a2. It would be the same checkmate. So let's say that the king goes to b2. And now I want to hear what is the move that would checkmate the white king now. It's a superposition move.
It's a1 and d5.
A1 A1 and d5. Then the problem is that the king can try to capture the queen here, and then either it will capture the queen, or the queen will collapse here, and it will be not a check anymore.
How about A1 and B1?
Yeah, so that's what I thought of. So this is the solution, because now here again the king is in danger, and here the king cannot escape by entangling, and the simple reason is because here both queen, so both of these indefinite pieces, the one with blue and the one with red, attack this field, this square, this B2. And then if the king wants to entangle, then it can only do it by staying and moving to somewhere else. So if it basically so if it wants to entangle, then one indefinite piece will have to stay here, and then it would either have blue color or red color. Now let's say it has red color, but then it will be threatened by this queen here, this one with the red mark. If we choose blue, then it will be threatened by the other indefinite queen with the blue mark. So there is no way out for white from this situation. Okay, so if it had been a quantum chess game, then Topalov could have won this game. Okay, so this was the end of the puzzles. So thank you very much for the interactive presentation, in this sense that you really knew most of the solutions, I think. So now finally I will talk some words about the variants, which we already touched upon because there were so many ideas how the rules could be changed. So here are some ideas. Basically, as you like. So you can introduce pretty much any quantum effect that you like, because this system of the marks and the rotations, it is very flexible. So you can see an example on the right side where the one mark is facing down or facing the opponent, the red mark is facing the opponent, the blue mark is facing upwards, facing the player, basically. So they are facing opposite direction. And then one idea is, which I actually have in the official version of the chess, is that this means an unequal superposition, meaning that when this knight collapses, then it will be more chance that it would collapse to red than that it would collapse to blue. So in my variant, it is that it would have if you roll the dice, then 1 to 4 will be red, collapse to red, and only 5 and 6 would mean that it collapses to blue. So it's an unequal superposition. So red has more chance to be collapsed, or the square with red mark will have more chance to be collapsed onto. Okay, so this is one idea, but you can also have another idea that, okay, let this be still an equal superposition, but with a relative phase. So in quantum computing, we would call it the minus state, right? That it's like an equal superposition, but with a 180-degree relative phase. Okay, this can also mean that it's really up to the educator or the one who is designing the rules. And also, you can do other rotations. You can work out a scheme where you can introduce like really complex amplitudes, like not only plus one, minus one, but also complex numbers, really. And yeah, if you have this, if you have the relative phase, then you can introduce something like the Pauli Z gate or even the Hadamard gate. If you have the unequal superposition, if you imagine that this is unequal superposition, then you can do something like, which is analogous to the Pauli X gate. Just take both pieces, and just turn them 180 degrees, and then you can have the additional rule that it is not the red which has the more chance, but it is the one which is facing the opponent. And then if you turn them, both of them, then it will suddenly flip the situation. But these are just ideas. This is not part of the official game. These are just ideas for educators. And then you can also introduce something like the partial collapse. So if you imagine that we have not only green and blue, sorry, not only red and blue, but also green, and then you can make like the piece into superposition where it occupies 3 squares at the same time. And then when you try to capture one piece, then it can result in a partial collapse that the knight stays in superposition, but only on 2 squares. So yeah, I'm talking to educators here mostly. Okay, and then there is a variant where we can have no randomness at all. So imagine that somebody tries to capture this knight here, and then instead of random collapse, we can say that it will induce a Hadamard gate. And then this is the minus state. So here, then it will be transformed that the knight will get classical here on the square with the blue mark. And then this way there will be kind of no randomness in the game, but I don't like it too much, but it's a possibility. And then my last word is that the limit is the imagination. You can come up with many different variants here. So this concludes my presentation, or actually I can quickly show one more thing about risk management, just 1 minute. So I say risk management because if you look at this situation, for example, then it seems that black has more chance to win, more than 50% chance to win. I mean, based on the strengths of the pieces. So black has a rook, while white has a knight only. But now, so white may think the same way, that, oh, I have less than 50 chance to win if we consider only the strengths of the pieces. But then the question is that, is this a good risk to take here? Because if white does this, then it will have a 50% chance that the black queen will collapse to e3, and then it would be an immediate checkmate. So then white may think that, okay, if I take this risk, then I have suddenly 50% chance to win. But if I don't take this risk, then I will have less than 50% chance to win. So is this a good risk or not? So, but if white is risk averse, then let's go back. Then the white may choose this to avoid this risk, because maybe white thinks that it has a better position because it still has a queen, which is classical, and then so it hasn't yet lost the surprise factor that it can suddenly move to 2 places at the same time, while black's queen is already in superposition, so it kind of lost the surprise factor. So that's why white may think that, okay, I don't take this risk, so I just block it, and I will figure out a way how to win this game. So if you play this game, I expect that you will have to make such decisions throughout the game. But okay, this was really the last thing I wanted to tell you, and I would like to thank you for your attention. It was a pleasure, and I think it's very important that I had some idea from you and some opinion about the rules, and I think this will be useful for the future when I want to make some change in the rules, maybe.
Tamás, thank you so much. I have one lingering question, which is, have you used this to try to educate people about quantum? Okay. So what kinds of experiences did you have?
I only had one experience where I explained this to children. So I made like a pilot, including my 2 children actually, and 2 other children. So they were between 10 and 12, and then I explained them basically these rules, but I also explained them this together with quantum mechanics. And I explained I did not do the entanglement in the first session, at least. I did only the superposition, the random collapse, and the tunneling, these moves. And this already gives you like an enjoyable game to play. And my experience was that, yeah, they could understand the moves at least. And yeah, they had some idea what superposition is, although, of course, it is super difficult to internalize this concept if you only have like one or 2 hours. But yeah, so I considered that session a success because the children were interested in solving the puzzles, and actually the puzzles that you saw, those 8 puzzles that you saw, most of them were from that session. So I used a small chessboard for the children, and actually maybe at that time I explained it better, but they could solve pretty much all of them. Yeah.
Very nice. How old are your children?
So the children were between 10 and 12.
Okay, all right.
So, but it's a very small sample. It was only 4 children. Okay, so it was not a. I don't consider it as a decisive thing, but it's like a good hint that that this can be used with small children.
Well, sounds exciting. Anyway, thank you so much for your presentation. I just want to point out that our next meeting is on, and I'm looking at my cheat sheet here just to make sure that I get it right, Wednesday, May 29th. And I know only the Eastern Daylight Time for that. It will be 1 p.m. Eastern Daylight Time. You have to translate to whatever time zone you're in on your own. I'm not good at that. And that talk will be about the world of processes described by the ZX calculus. We hope that everyone in this meetup group and everyone in the world, everyone in the universe will attend that meeting. Once again, thank you, Tamás. Thank you, everybody, for attending. We'll see you next time.
Thank you very much for attending and inviting. Yeah. Bye-bye.
Very fun presentation. Thanks.
Thank you very much.